Hello, my name is Elizabeth Sweeney. I'm the Mass Balance Advisor for Chevron Downstream Manufacturing. Today I'd like to talk to you about how Chevron is using Sigmafine to improve gross margin at our refineries. I'll start with telling you a little bit about Chevron's refineries and then Chevron's Sigmafine journey. I'll talk about current Sigmafine projects within Chevron, our business objectives, including the users, business data customers, and architecture, and then I'll do a brief summary. Chevron operates 5 refineries that produce a variety of fuels, base oils, and other products. Together, Chevron's refineries can process almost 1 million barrels of crude oil per day. Our first refinery was built in Richmond, California in 1902. Our second in El Segundo, California in 1911. In 1948, we built the Salt Lake City, Utah refinery. In 1963, the Pascagoula refinery was built, and that is currently Chevron's largest refinery in the U.S. And then recently, we acquired in 2019 the Pasadena refinery in Texas. It was originally built in 1919. So Chevron's journey with Sigmafine started over 20 years ago. So prior to 2010, we had various independent projects. In Pascagoula around 2001, we initiated the Rambo project, which was the Refinery Accounting Mass Balance Optimization project. It was our initial Sigmafine deployment for Chevron. It also included implementation of the OSI products, the Pi Systems process book. Those were all installed. And focus there was to replace our legacy inventory and yield accounting systems. Later on in 2008, in El Segundo, we upgraded to Sigmafine 4.5. And then we also developed some software that served as the front end to Sigmafine. We called it Promise, which is Process Monitoring Information System. And then at the time, we had Pembroke Refinery in the United Kingdom. They had Aspen's Advisor that they were using for mass balance. Then in 2011, we had the Global Manufacturing Mass Balance Project. This expanded the use of Sigmafine to all of the equity refineries. We started doing daily mass balances. Sigmafine was chosen over the Advisor application because of better support and more recent investment, and it was more easily integrated into our existing OSI Pi infrastructure. And today we're expanding the use of Sigmafine to enhance refinery performance monitoring and improve our gross margin. Within Chevron, we use Refinery-Wide mass balances. So we're using Sigmafine to reconcile hydrocarbon movements within the refinery boundary, which includes feed and product meters for the process units, tank inventory and transfers within the refinery boundary. And then we're also looking at boundary movements like marine, pipeline, truck, and rail car shipments and receipts. We include all hydrocarbon streams within the refinery, but we do not do a fuel gas system balance, and we do not currently include water or steam. We're monitoring refinery imbalances on a midnight to midnight basis. And we perform 2 types of reconciliation. So we're doing the mass balance analysis rule, and we're also using composition tracking analysis for our crude tanks. The primary metric that we track on a day-to-day basis is the DX1. So that is calculated by Sigmafine, and we target less than 5% on a daily case. So I wanted to talk to you about 2 of the projects that are currently in flight within Chevron, the Oils Movement Program and the Gross Margin Improvement Project. So I'll start off with the Oils Movement Program. I talked a little bit about this a couple of years ago in the Sigmafine Summit. The program is a collection of projects that include 6 work streams. The first is tank field management, which is kind of the internal refinery movements. And then secondly is the marine movement and scheduling. So that includes dock management and dock scheduling. The next work stream is rail and truck movements. We also looked at meter flow compensation and then production accounting and mass balance. So the goal of the oils movement program is to replace our obsolete marine scheduling, oils movement, mass balance, and production accounting systems. It's actually part of our digital transformation. The goal was to provide an integrated set of standard systems to meet all of our functional requirements while reducing the cost of ownership by using sustainable vendor solutions. So as you can see at the diagram over to the right, we had a variety of different applications at each site. We were using a collection of Excel spreadsheets, different applications from one site to the other. Some applications didn't integrate with other applications. So oils movement was really all about standardizing the applications and picking applications that would communicate well with one another and that we had dependable vendors who could support those solutions. Under the oils movement program, as we started to study our infrastructure, we realized that we were going to need a few more applications to fill the gap that Promise was going to leave when we decommissioned it. So a couple of the things that we picked up, one was the Sigmafine integration framework. So we needed that to connect to a variety of source systems. So that being Yardmaster for the rail cars, we had the Honeywell profit movements management that was giving us all of our tank to tank, unit tank, blending, pipeline, and marine movements. That will connect with MES to give the marine movements. And then we also have our meter data coming in. We're also looking at an SAP integration to pull some truck information down from SAP. So all of that's going to be processed through the Sigmafine integration framework. We are using at least a portion of the intelligent movement management software to provide a tank calculator. Several of our users just needed to, quickly calculate a volume from a gauge reading. So we put in this. We use parts of intelligent movement management to give them a web-based application to do a tank calculator. And then through the integration framework, we were running our Sigmafine models. Under oils movement, we did have to update our models because they didn't have everything in there that was needed to produce a refinery stock balance for finance. And then on the back end, we needed to be able to report the results. So we needed the Sigmafine SQL Access. So we're writing to Pi and to SQL using the Sigmafine SQL Access. So the information that we write to Pi are the reconciled mass and volume that comes out of the model, and then everything that's in the model, including the tables and everything, goes into the SQL database, and then that's available for external reports. We also have a backend integration for SAP. We needed to be able to send the monthly production numbers to SAP for gross margin calculations. The second project I wanted to talk about today is the Gross Margin Improvement Project. So this project was initiated in late 2019. However, due to the pandemic, much of the work had to be completed remotely. Although it was timed right, as a result of the pandemic lockdowns, the demand for refined products fell sharply, which led to negative margins for much of 2020. In addition to that, Chevron cut nearly 15% of our workforce. So we had to learn quickly how to better utilize our resources and our technology. So gross margin was key to that. The objective was to move lagging and average processes to industry best in practice so that we could unlock additional gross margin at our refineries. There were two focus areas: planning improvement and performance monitoring. Within the planning improvement section, we looked at feedstock selection, AOP, which is an area operating plan and price forecasting. And then under performance monitoring, we looked at material balance and monitoring, backcasting, and constraint management. So we wanted to target leading best practice for material balance and monitoring. And we're going to do this through daily balances and yields that reconcile the fence line stock balance with process units to produce an accurate single version of the truth. So Sigmafine is at the core of the material balance and monitoring capability. The gross margin improvement project was completed first at the Pascagoula refinery, and we're now implementing the GMI tools and processes at El Segundo and Richmond refineries. Data component architecture. So we already kind of had the source systems under oils movement and those connecting into Sigmafine. So now that SQL database is accessible to the new tools that were being built for gross margin improvement. So we're combining information from Sigmafine with information from our planning tools, Petro APS, and then that we created a new set of reports and dashboards that are accessible to everyone in the refinery, including management and corporate. Gross margin improvement is about more than just producing Power BI dashboards. We realized early on that work process reviews and change management were going to be key to the adoption of the tools and to the overall success of the project. One of the things that we did for change management was develop these day-in-the-life narratives to help with the transition. I won't go through every detail on here, but we have a day-in-the-life snapshot was kind of like, what does this person do on a daily, weekly, or monthly basis? This one in particular is for stock accounting. So it kind of gives a brief description of their role and how they're going to shift from working the way they used to work to using the new GMI tools and processes. And we really wanted to focus on how this person can drive value through gross margin improvement. So time savings was a big one for finance. They spent a lot of time compiling, gathering information, making spreadsheets and reports. So we wanted to give them the dashboard so that they don't spend as much time on gathering the data, but they can spend more time using the analytics and gaining insights from the data. There's an awful lot more coordination and collaboration with the oils planning. Before, finance was kind of in a silo. They did their own thing, and then they sent the report to oils planning at the end of the month, and then oils planning, did what they did with it. There's a whole lot more communication and collaboration between the two groups now, and we're moving towards this one source of truth, which increases the trust in the data. So a big thing is oils planning and finance are now using the same tool to produce stock balances. And that has really led to people trusting the data more than they did before. So this is another day in the life narrative that we put together for the mass balance engineer role. The mass balance engineer drives value through this gross margin improvement project by enabling better data quality and more trust in the data. So the mass balance engineer is responsible for running the daily cases, and they provide accurate stock balance, providing foundations to enable improved downstream processes. So we kind of moved from only focusing in on the DX1 to more looking at the refinery liquid volume recovery every day. So that gives you a better indication really of how good your case is. Proactive troubleshooting and addressing equipment and unit issues daily to drive cost savings. We would find these things in our old process, but they weren't found on the day they happened. They might be found a week later or a month later or several months later. So we're catching these things faster now and addressing them sooner, which has really been an improvement. And then enabling greater visibility into the yields. So we're really getting into yield analysis now, where before it was just kind of ad hoc. So this has really been a huge improvement. So we now have a wider array of business data customers, obviously including oils planning and finance, but now expanded to operations, process control, process engineering, instrumentation maintenance. Environmental kind of was a big surprise when we went through the gross margin improvement work process studies. There's an awful lot of information that gets pulled out of the stock balance for environmental reporting and out of the mass balance for environmental. And government reporting was another one. So we're now pulling the EIA reports that have to be done out of the GMI tools. So in summary, Chevron is transforming production accounting and data reconciliation systems and work processes. The Sigmafine system is now part of Chevron's core business processes, no longer a discretionary work process. And we've experienced a significant reduction in time due to the elimination of redundant work processes and moving towards one version of the truth for stock balances. So thank you for your time today.